This is a brief introduction to the NASA IPAC Infrared Science Archive, or IRSA. Just for a bit of context, the role of an astronomical archive is to both ingest new data, but also reprocessed versions of old data. We also have to maintain and serve these data as part of a repository of completely irreplaceable data. As a NASA archive, not only do we have to provide support for observation planning, we also have to provide support for mission planning. Of course, we have to be a resource for original science, and we also have to serve high-level science products, by which I mean data products that are ready to use for science right now. We have to enable cutting-edge research, and we do that by supporting APIs, application programming interfaces, and supporting the virtual observatory efforts. We provide user support by experts. We provide new and enhanced services all the time, and we support multi-wavelength projects. Having a good archive doubles the scientific output, and you can see that in many different ways. Here are two plots with unfortunately slightly different color schemes. This plot here talks about the Spitzer archival data usage. This is the fraction of journal articles coming out as a function of time. The blue wedge here is papers written by people who requested the data that they're presenting in the paper. The green wedge here is people who didn't request the data that they're publishing on. The red wedge is papers that are presenting both data that they requested and archival data. And you see here that half of the journal articles are talking about data that they themselves did not request. This is another view. This is from Hubble. Unfortunately, colors are a little bit different. Here, this is total number of papers. The blue is PI or non-archival data. The red is archival data, and the green is both. So having a good archive means you get twice the amount of science out. IRSA is based at IPAC. IPAC at Caltech advances the exploration of our universe through many different ways: science operations, data archiving, and also community support. IPAC was founded in 1985 to support IRSA, which was the first all-sky infrared survey. IRSA is one of the largest, oldest parts of IPAC at Caltech. IRSA is NASA's infrared science archive. Our charter is to provide an interface to NASA infrared and submillimeter datasets, so like a micron to a centimeter. It was founded in 1993, and as I said, it's the original home to IRAS data. About 15% of all refereed astronomy and astrophysics journal articles published today use data that ultimately came from IRSA. We have more than 5 petabytes of images and more than 240 terabytes in databases and counting. We have all-sky coverage in 24 bands. There are many different ways to connect with IRSA. We have a website and help desk, of course. We have email newsletters that come out about once a month. You can sign up to get these online. We also have social media, both Facebook and Blue Sky, and also YouTube. We have tutorial videos there. They're a little bit out of date right now because we relatively recently rolled out a new look and feel for our tools, but we'll be coming out with new videos soon. There's lots of different ways to get data at IRSA. We have user-friendly web interfaces that provide really powerful tools for visualization and data discovery. We have virtual observatory-based APIs or application program interfaces to our tools. That means you can access IRSA via Python or command line tools. We also have something called Fornax, which used to be the science platform. That's science computing in the cloud. We have Python notebook examples for doing that and for using the APIs. For the rest of this talk, I'm just going to give you some brief screenshots of what the web interfaces look like to give you an idea of the visualization capabilities that we have. This is the IRSA website. This is just one of the tools that we have. This one is called Finder Chart. It's one of the most popular tools that we have. It gives you the same chunk of sky from many different surveys at many different wavelengths, and you can overlay catalogs on the images and interact with the images and the catalogs and the plots from the catalogs. This is IRSA Viewer. This is the most generic version of this tool that we have. You can pull many different images from many different surveys simultaneously, and you can overlay catalogs from multiple sources on the images. You can make plots, and again, interact with the images, the overlays, the plots, the catalogs, and explore which sources are where in the plots and in the images and the catalogs. We also have substantial and growing spectroscopic visualization capabilities. This screenshot here comes from extracting a spectrum from that image cube that's on the left. The cube that's on the left actually has 100 planes that are parallel to the screen. The spectra that have been extracted have poked through the cube perpendicular to the screen to get the spectrum on the right. There's actually 4 different spectra extracted here that are listed in table form on the bottom and plotted on the right. This is another spectroscopic representation. In this case, this is Spitzer data, where there are 4 different orders shown in different colors on the same plot. We also have time series capability. This is WISE data, where I've determined the period of half a day for this particular object. And you can see along the bottom, it's extracted the individual frames from which the photometry has been obtained. So I can explore individual points and the images from which those points were derived. You can also use a tool called DCE, or Data Collection Explorer. The Data Collection Explorer, as its name implies, allows you to explore what data exists in many different data collections. Here on the right, you see an all-sky map. All the yellow footprints are where there are data from the 2-mass Large Galaxy Atlas. In this particular case, I've searched on M101, which is here, but I can zoom around in this image on the right, and I can explore different collections by selecting them here, and it'll show me the footprints here on the right. I can also use IRSA tools to search the virtual observatory. This is setting up a search using the Canadian CADC OBSCOR data product tables. I'm going to search on NGC 2264, and it found 37,000 different observations through the virtual observatory of NGC 2264 from all over the world, and I can use IRSA tools to explore what these data products are. I can also, through IRSA tools, use something called VO-TAP. TAP is Table Access Protocol. I can use the TAP services, again, all over the world. This is talking to the CDS service in France that allows me then to search different journal articles, and I can use this IRSA service to talk to the tables at Vizier and find different data tables there, again, to load into the IRSA tools. The newest tool that we have here at IRSA is the Euclid Data Explorer. Here, too, you can use the tool to explore where there are data. So in the Euclid Data Explorer, the yellow footprint is where the observations are planned for Euclid, and the red footprint is where the data have been released. So in this particular case, I'm going to search in this little red footprint here. It's given me back a list of images and a list of objects, and it's overlaid the objects on the images here. So there's lots of tools at IRSA that enable you to explore all of the data that we have here at IRSA.